Yes, welcome. Like I always say, it's Math with Ms. B. We're doing what is a linear function today. Take some notes out. Don't act like you're just gonna get it. And let's go. Math with Ms. B. Math with Ms. B. There's 1,000 other places that you'd rather be. But you're watching Math with Ms. B. A linear function is a function with a constant rate of change, a straight line graph, an equation that has no exponents on the variable or variables as exponents. Ding! Does the table represent a linear function? So first of all, we have to say, is the rate of change constant? What do I mean by that? I'm going to tell you. Look at the x column. Everything's increasing by 1. That's constant. But we also have to look at the y column. Everything's decreasing by 3. Also constant. Is the rate of change constant? Yes, this is a linear function. It's that easy! Yay! Okay, so we'll do the next one. Constant rate of change, right? 1, 1, 1, 1, 1. And then we have -3, -1, +1, +3. Is that constant? Not og. No, so it's not linear. Okay. Good. +1. Great. Constant on one side. But what we got on the other side? Plus 0.25, plus 0.5, plus 1, plus 2. That's not going to work out for us. Not going to work out for us. The middle one is quadratic and the last one is exponential. But that's just free knowledge. That's free game. Does the table represent a linear function? So you should do these on your own. So pause the video and try to figure it out while I drink some of my smoothie. Okay, hopefully you paused the video. Is the rate of change constant? Well, let's look at that first one. +1, +1, +1. +1, +3, +5, +7. Ooh. Not going to work out for us. +2, +1, +1, +2. +4, +2, +2, +4. Yes, it is linear. Wait, but you said it had to be constant. Well, guys, if I put a -3 in the middle of that -4 and that -2, that would still be a +1 jump. And if I put a 3 in between 2 and 4, that would still be a +1 jump, right? So I actually skipped numbers in the table to trick you. Okay, so make sure you pay attention to that. So yes, that one is linear. +3, +2, +1, +1. Yes, also linear because I'm skipping. You got to pay attention to what you're skipping, right? So if I filled in the missing -4, the missing -3, if I filled in their y values also, I would see that I had a constant rate of change. So what you really want to pay attention to when it's skipping stuff is you want to pay attention to the ones that are consecutive. Okay, does the graph represent a linear function? So the question that we're asking ourselves in this one is the graph a straight line? So easy, so easy. So for the first one, I have a straight line, don't I? So yes, it is linear. For the second one, not a straight line, so it is not linear. Third one, it's still a curve, so it's not, I couldn't put a ruler to that, so no, it's not linear. Try these ones on your own. Is the graph a straight line? I will drink my smoothie. All right, the first one, no, not linear. The second one, yes, linear. The third one, yes, linear. That's so easy. That's not even like really math. Okay, does the equation represent a linear function? Yes or no? The question that we are asking is it an equation with no exponents on the variable or variable as an exponent? Okay? Those things, if there's exponents on the variables or the variable is an exponent, cannot be linear. So, first one, yes, it is linear. Passes the guidelines. Second one, no, it's not linear because it has a squared, an exponent. That's quadratic. We're not doing that. No, not linear. Because the x is an exponent. You see how it's tiny up there? That's an exponent. The variable is an exponent. Not allowed. Yes, this is linear. Yes, this is linear. Yes, this is linear. Fantastic. We love to see it. Again, you got to try on your own. That means pause the video. All right. Is it an equation with no exponents on the variable or a variable as an exponent? Yes, this first one is linear. No, because exponent of 2, not linear. Yes, this one is linear. Yes, this one is linear. No, not linear because it has an exponent. No, not linear. You also cannot have variables in a denominator. I should probably add that to the definition. So I tried to trick you on that one. Sorry if I gotcha. So sad. Okay, anyway. That's that lesson. Really easy, really straightforward. Go back, see if you can do it without my help. Tell your auntie, tell your mama, tell your grandma and her kids and your fake cousins and your play cousins, and like, subscribe, all that jazz. I'll catch you in the next one.